This will be a very short video, but I didn't feel like it fit in any of the other sections, so I've made it a standalone video. It's common for them to ask you to simplify functions before you integrate them, and you do this using trig identities we've learned in previous chapters. So here's a very easy example of this, where we need to integrate tan squared of x, and this is actually on the specification as an example that they could ask you. So when we look at this tan squared of x, on its own it doesn't look like something we can integrate straight away. But what we can do is we consider the identities that we learned in previous chapters, and specifically the ones that we learned back in chapter 6 in year 2. I did a video on them called Trigonometric Identities and Equations, so go back to them if you need a reminder. But we talked about the identity that 1 plus tan squared of x is equivalent to sec squared of x, okay? And we have a tan squared of x here. So what we can do is we can move this 1 onto the other side, so it becomes tan squared of x is equivalent to sec squared of x minus 1, and therefore we can sub out this tan squared of x for this sec squared of x minus 1 like we've done here. So we need to integrate this now, and this is really useful to us because we have two terms here now, sec squared of x and minus 1. So if you consider them individually, well, this sec squared of x we've already talked about in a previous video about how to integrate this. This is one of the standard integrals you need to know. It's actually also given to you in the formula booklet of when you integrate sec squared of x is equal to tan of x, like this here. So this is very easy for us to integrate. And the minus 1 is very easy to integrate. We talked about it in year 1 integration. When you integrate minus 1, it's just minus x like this here. So therefore just add these terms together. So therefore it's going to be tan of x minus x, and then remember the plus c on the end. So that is how you integrate tan squared of x. We needed to use trig identities in order to get it into this form here so we could integrate it. Okay, so here's another example where we need to integrate sin squared x, and like the last example, this is actually mentioned on the specification as a type of question that they could ask you. So again, we cannot directly integrate this sin squared x, so we're going to have to change it. And the way that we're going to do this is by using the double angle formula that we learned back in year 2 of chapter 7, and specifically the double angle formula for cos 2a that involves this sin squared a. And what we're going to do is going to make this sin squared a here the subject, so therefore we can sub out this sin squared x. Okay, so if we do this, so if we first move this 1 onto the other side, so it becomes cos 2a minus 1 is equal to minus 2 sin squared a, and then we're going to divide both sides by this minus 2 here, so we get that half minus half cos 2a is equal to this sin squared a. Okay, and therefore what we're going to do is this sin squared x, instead of a here we're going to have x, we're going to sub out this sin squared x for this half minus half cos 2x, okay? And this here we can integrate, okay? So we have two terms here, so let's consider them individually. So if we start with the integral of half dx, this is just year 1 integration, this is equal to half x. And then if we integrate this minus half cos of 2x, now we have this coefficient in front of the cos 2x, this minus half, and as I talked about before in this chapter, we can move this out of the integral like this here, so it's minus a half and then the integral of this cos 2x here, so we can focus on this. And we talked about how to integrate stuff like cos 2x in the last video titled integrating f ax plus b, so go back to that if you need a reminder. But the way that we integrate stuff like this is, so firstly we integrate the cos, and when you integrate cos it's sin, so it's going to be sin 2x, but we also need to divide by the coefficient of x here, which is 2, so therefore it's going to be half sin 2x when we integrate this cos 2x, and then we need to multiply it by the minus a half that we took out at the start, so it's going to be minus a quarter sin 2x. Okay, so if we add these two terms together, when we integrate this, it's going to be equal to half x minus a quarter sin 2x, and then remember the plus c on the end. So here's another example where we have to integrate cos squared of 3x, and this is also on the specification, and this is very similar to the one before. It's a very similar method because again we can't integrate this directly, so we need to change it somewhat, and the way we're going to do that is by using the cos double angle formula, but this time we're going to be using the one that has the cos squared involved because we have the cos squared here as well, so hopefully we'll be able to make some sort of substitution. So if we move this minus 1 onto the other side, so it becomes cos of 2a plus 1 is equivalent to 2 cos squared of a, and then divide both sides by 2, so we get half cos of 2 of a plus a half is equivalent to cos squared of a. So you can see that we have this cos squared on its own now, and what we're going to do is we're going to substitute this in by saying that a is equal to 3x, so a is equal to 3x, so that means that this 2a on this side is going to be 6x, right? So if we sub this in, it's now going to be the integral of half cos of 6x plus a half like this here, and this here we can integrate. So we have these two terms, so let's take them one by one. So if we start with this half cos of 6x, and we can take this half out of the integral like this, so it's half and then the integral of cos of 6x. This is similar to the previous one as before, so remember there are two steps. Firstly, we have to divide by the coefficient of x, which is this 6, so it's going to be 1 over 6 like this here, and then we need to integrate the function here, which is the cos. If you integrate cos, it becomes sin, and then it's still going to be the 6x like this here. Again, go back to the previous video if you need a reminder of how this works, and then half times 1 over 6 is 1 over 12 sin of 6x like this here, and then the half here, if you integrate this, is just equal to half x. So if you add these terms together, it's going to be 1 over 12 sin of 6x plus half of x, and then remember the constant of integration as well. Okay, so here's one final example where we need to use trig identities in order to simplify an integral. So here we need to show that the integral of 1 minus cos x squared over sin squared of x like this here can be written in this form. Okay, so we need to integrate this here, and as we've got this bracket in the numerator squared like this here, it makes sense to expand this bracket to start off with. So if we do that, you can do it the long way if you want to, but the easy way to do it is if you do 1 times 1 is 1, and then minus cos of x times minus cos of x will be cos squared of x like this here, and then 1 times minus cos of x twice will be minus 2 cos of x like this here. Again, you can do it the long way if you want, expanding this bracket if it makes it easier for you, but this is this bracket here expanded, and all of this is still over sin squared of x. And then what we can do is, as we've got 3 terms in the numerator and 1 in the denominator, we can split up this fraction like this here, so it becomes 1 over sin squared x minus 2 cos of x over sin squared of x plus cos squared of x over sin squared of x like this here. And we can simplify this further because 1 over sin squared of x is equivalent to cos x squared of x, and then this minus 2 cos of x over sin squared of x, well, we can split up this fraction like this down here, so it becomes minus 2 cos of x over sin of x times 1 over sin of x, and then cos of x over sin of x is cot x, and 1 over sin x is cosec of x, so we can write this as minus 2 cot x cosec of x, and then this cos squared of x over sin squared of x is equivalent to cot squared of x like this here. So we need to integrate this where we have these 3 different terms, so let's do them one by one. If we integrate cosec squared of x, this is one of these standard integrals that we talked about in the first video in year 2 integration that you need to know of. When you integrate cosec squared of x, you get minus cot of x like this here, and then if you integrate minus 2 cot x cosec of x, I've taken the liberty of taking this minus 2 out of the integral like this here. If you integrate cot x cosec of x, this is another one of the standard integrals that we talked about in the first video. You need to know about that this is equal to minus cosec of x when you integrate cot x cosec of x. So then this is going to be minus 2 multiplied by minus cosec of x. These two minuses cancel out to leave us with 2 cosec x. So then for this third term, the integral of cot squared of x, this is not one of these standard integrals that we talked about in the first video. We can't integrate this directly, so we're going to have to change it in some way. And the way that we can change it is, if you recall back to the identity that we talked about in chapter 6, that 1 plus cot squared of x is equivalent to cosec of x, like this here. You can see this cot squared of x, so we can make a substitution. So if we move this 1 onto the other side, we get that cot squared of x is equivalent to cosec squared of x minus 1, and then we can sub this in for cot squared of x, so it becomes the integral of cosec squared of x minus 1, like this here, and we can integrate this easily, because we've already talked about the fact that when you integrate cosec squared of x, it becomes minus cot x, and then minus 1 integrated is just minus x, like this. So what we can do now is, if we add these terms together, like the ones here, it's going to be minus cot x plus 2 cosec x minus cot x minus x, and then remember the plus c on the end. Then we can simplify this because we've got 2 minus cot of x, so this is equal to 2 cosec of x minus 2 cot of x minus x plus c, which is what's required.